Okay, define and calculate conditional probabilities. So this is going to be 8D. Okie dokie. So, what does conditional mean? Conditional means that you have been given some extra information. I've got a wiggly line under that for later, but all I'm getting at right now, so if we're dealing with conditional probabilities, it means you know some extra piece of information. So, for example, I roll a 6-sided die, 1d6, and I'm looking at it, you can't see it, and I tell you, oh, it's an even number. Well, I've given you some extra information. So, it's a 6-sided die, we already knew that, but I've also told you it's an even number. Okay, great. What does that mean? Well, it means that you know that it can't be a 1, a 3, or a 5. So if I asked you, okay, what's the probability of it being a 6, you're not going to say 1 in 6 anymore, you'd say 1 in 3. If I had a normal 52 card deck, cool, and then shuffle them around and I look at it and go, oh, it's not a face card. Well, we know it's not a face card now, so we can exclude the jack, the queen, and the king. And similar story, if I've got a random number generator that's rolling numbers 1 to 20, and I look at it and I go, oh, it's prime. Then that's an extra piece of information, so you can make a better guess as to what the thing is. Okay, so the mathematical way of writing this stuff is probability of A given B. So this vertical line, it's not an I, it's a long vertical line. We usually call that a given. Hence why I've got the wiggly line under given. So sometimes people will call these conditional probabilities, sometimes they'll call them givens. Same thing. Cool, so probability of A given B is equal to the probability of A intersect B divided by the probability of B. Now why does that work? Well, let's think about it for a second. We want the probability of A happening given B has already happened. Alright, well if B's already happened, the only way A can happen is if the intersection of A and B is what we're talking about. So only A intersect B can happen for A to happen now, because if it was A that wasn't intersecting with B, well B's already happened, so we can't be in that space. And then we know that B has already happened, so it's out of the total possibilities of B. Now it's not 100% necessary that you totally get that, but if you draw a Venn diagram it usually helps you to solidify it. Obviously you can email me if you're really curious about absolutely fundamentally understanding that and you can't quite get there, that's fine. Cool, alright, so let's give this some examples to flesh it out some more. Alright, 20 students in a class, 13 do methods, 9 do physics, 3 do neither. Given Jimmy does methods, what's the probability he also does physics? So normally you wouldn't be given that, you'd have to figure it out, but for the sake of saving time, cool, I've got methods, physics, neither. Okay, well, we were given our formula before, so what am I going to define as what? Well, I need probability of A given B. Alright, well A and B doesn't help me too much here, what do I actually want? Given that he does methods, so that's on this side, what's the probability he does physics? So probability of physics given methods has already happened. Cool, so we know that he does methods, what's the probability he does physics? Yep. Okay, well that's the probability of physics intersect methods over probability of methods. Okay, great. Probability of P intersect M, that's in the middle. 5 out of total was 20, over probability of methods was over on this side, 13 out of 20. Cool, well we've got a 20th divided by a 20th, so they'll cancel, so we get 5 on 13. Beautiful, done. Now, does that make any sense intuitively? Well, let's think about it. Given Jimmy does methods, okay, so we have to be in this circle. Well, there's only 13 kids in that circle. What's the probability he does physics? Well, he does physics would be in this part, so 5 out of the 13. Well, there you go. Works like a charm. Cool. Another example. In a class of 15, 10 have black hair, 8 have brown eyes, 3 have neither. As in, they don't have black hair or brown eyes, not they don't have any hair or any eyes, because that'd be a little bit weird. Given Jane has black hair, what's the probability she doesn't have brown eyes? Okay, well this time I've done it in a 2x2. You could do it in a Venn diagram, that's fine. I just decided to change it up a bit just because. Okay, and again, you'd have to work through and fill out all your values, but just sped that up a bit. Okay, great. What do we want? Given Jane has black hair, okay, so probability given Jane has black hair. Notice that black and brown both start with B, so I'll put K's and N's. So given that it's black, what's the probability it's not brown? Okay, well, we know from before, this is the probability of not intersecting with that over probability of black. Cool, okay, well, conveniently now, I've got this in a setup where I can actually just read that off. That would be this guy, so that's 4 over, was it 15? Yep. Probability of black is the total, 10 out of 15. Cool, which gives me 4 over 10, but I should always simplify, 2 out of 5. Beautiful. And that's that. This isn't overly onerous at this stage, it's just one extra complication that we can throw at you. This can get a little bit more onerous once we start doing a series of events, but we'll do that next time. Cool, so that's 8D. Email if you got questions. Bye.